Welcome to a lecture dedicated to application protocols. In this session, we'll examine the protocols of the two highest layers of the OSI model. Let's start with the presentation layer. Presentation layer protocols are responsible for encoding, decoding, and displaying in applications the data sent by the lower layer protocols. This is kind of a standard interface between, for example, an application written in PHP, a website written in ASP.NET, and data transport protocols. The implementation of presentation layer protocols is crucial for the safety of the entire network application. Let's discuss a few examples. The first one concerns the Iis Server. This is a Microsoft web server. One of the earlier versions of the server allowed anonymous access to the hard drive of the computer the Iis was installed and run on. The attackers only had to properly encode the request for access to a selected file in a hexadecimal format. The Iis server rejected the HTTP GET requests for files to which a website user should not have had access. However, if a hexadecimal number which encoded the file's directory was given as the GET request attribute, the Iis server fulfilled the request. One should not be able to browse a web server folder structure. To prevent this, the Iis server checked if anyone used a combination of characters // If someone tried to use this combination, the request was blocked. However, the same request encoded as %C0%AF was fulfilled. The problem was that the same thing could be encoded in many ways. If you try to secure an application with the mechanism checking if an action is hostile, with the default assumption that it's not, you'll fight a lost battle. When you create a line of defense, you always have to show ingenuity. You have to imagine how else the request can be encoded. So in the example mentioned, all possible ways of encoding a request should be blocked. But such an approach is simply impractical. A typical problem of presentation layer protocols is the null byte injection. Many network applications are created in high-level programming languages: PHP, Java, Perl, ASP.NET. These languages use environments, or frameworks, written in another language, usually C or C++. In these languages, end of string is marked in a special way. In C or C++, the string doesn't have a specified length. The string ends with null characters, or zeros. This means that everything that comes after is ignored. Let's look at a few examples. Suppose that you write a script in PHP allowing someone to download files with the DAT extension. We could do it as it's shown. This is a simple function allowing us to download a DAT file with the name specified by the user. The function will work properly if the user executes it in the following way: http://www.server.com user php file myprofile.dat. But what happens if the function is executed in the following way: http://www.server.com user php file equals ://etc/password null. At the end of this command, we see a null character, indicating the end of the string. In this case, the extension dat will not automatically be added. The problem with translating expressions between different platforms and different ways of encoding means that a function can be executed differently than its creator had intended. This is a simple and universal example. It doesn't apply to PHP only. We see a similar function written in Java. It will be used for reading files, this time with the extension db. This time too, the correct request, namely server.com/mypage.jsp?fn equals report.db, can be replaced by the following. server.com/mypage.jsp?fn equals serverlogs.null.db. Again, the attacker uses the function in a way the creator hasn't thought of. The problem is that the issue doesn't concern only the specific web application of company X. This is the issue of the environment or the language in which these applications are created. This is a very common problem. That's why many applications are susceptible to null byte injection attacks. It doesn't mean that the applications are poorly written. It just means that they're written in a specific environment. Some environments can be exploited, which means that they allow for certain requests to be encoded in another way than expected.